Everything in transformation, like all the theory parts. Today we talk about a challenging question. Well, this question I think is focused on transformation because it requires you to do everything in transformation. So for the first two, it's not. Let's have a look at the question. A function f(x) equals to 2x minus 1 undergoes the following sequence of transformation. Okay, in order. Okay, that's in order. So first we have a translation of one unit in the positive direction of the x-axis. Okay, a translation of one unit in the positive direction of x-axis, we have x dash equals to x plus 1. That's what we will have. And then two units in the positive direction of the y-axis. So we have y dash equals to y plus 2. A reflection in the y-x-axis is change x. So I will times that by -1. A dilation of factor 2 from the x-axis, that's change y value. I will times 2 here. A reflection in the line y equals to x. Okay, so your new x is x plus 1 times -1. Your new y will be y plus 2 times by 2. Now you will change xy. What you change now is not the original xy. What you change is the new x and new y. Because after all this transformation, you have a new point now, like new point x, new point at y. So what we'll do is we'll swap x and y here. Okay, we'll swap x and y here. Not swap the xy, we swap the x dash y dash. Okay, we change x dash to y dash, we change y dash to x dash. Because the reflection in the line y equals x happened after all of this transformation. Okay, if it's at the beginning, yes, we can swap x and y because that's the original point. But now after all of this transformation, my point already changed and then I swap the xy. So what you need to do is change x dash to y dash, change y dash to x dash. So now that's your new coordinates of the graph. So find expression for the transformed x dash y dash coordinate in terms of xy. So you can just copy that here. Okay, you can just copy that here. So we have x dash equals to 2 bracket y plus 2 and y dash equals to minus bracket x plus 1. Okay, B says use the equations from the previous part. Okay, I can say hence. Okay, I can just get rid of all of that. That can become hence. Well, I don't need to change it. Like that will be equivalent to hence. Hence means, okay, be careful with hence question. For one question, there's always multiple ways we can do it. Like there's maybe 2 or 3 ways you can do it. But if it says hence, you must use the result from the previous part. Well, maybe not previous, like if it's C, not necessary to be B, it must use A or B's solution. Okay, A or B's answer. So you must use the result, what you have found out from the previous parts. Well, you must use it. You can't use your own way to do it. If it says hence or otherwise, then you can use any method. But when they say hence, which means there's an easy way if you can use the answer from the previous parts. If you use the otherwise method, that means you go to a long way. Okay, so if it says hence or otherwise, which means if you use the result in the previous part, will be easier. Okay, will be easier. So now we can see it asks us to hence find the image of the point A under this transformation. Okay, under this transformation. So this is the original point x and y. It is the same as what we learned yesterday. Give you the old points, and I want to see after the transformation what is the new point. So basically, this is the substitution question. X dash is 2 bracket -3 plus 2, and x dash give you -2. Y dash equals to minus x plus 1. Y dash equals to -6. So the new coordinates will be -2 and -6. That's the new point. Okay, these two are like regular questions. Like, okay, if I want to know the, okay, what all ask us to do after is just on purpose ask us to use transformation. This question, I can directly do A, and B is something is not really, doesn't matter. So I can do A and then directly go to the last one. The last one is asking us what's the equation under this transformation. What I can do really easy is I can make xy to be the subject. And then substitute into the original equation. I will get the new function, right? I will get the new function, definitely. So I can finish A directly to G, okay? But like all it asks us to do in between, just want to test our matrix ability, like calculation of a matrix, understanding in matrix, like this is just on purpose testing a matrix. That's what I mean, like when I'm teaching matrix method, exercise. I said like I don't really like use matrix to do transformation. I think it's quite silly. It's just go for a long way. Just replace the word description into a matrix, and we need to go back to an equation as well. It just go for a long way. But some question like this will force you to use matrix method. So that's why you need to know matrix. Okay, you need to know matrix. Let's have a look. The above sequence of transformation can be described through the matrix equation, where x is xy, x dash is x dash y dash. Show that the matrix T and B can be written in this way. Yesterday when I returned the paper to you, like the chapter 1, chapter 2 test, I see there's a show that question, and some of you still don't know what is a show that question. For a show that question, you can't use the answer given in the question. For example, in this question, show that this matrix is this and that. In your working, you can't use that one. You can't use that one. This question will be the same as find T and find B. Okay, find T and find B. You don't know what is T, you don't know what is B. You are asked to find it. And then the result you find should be the same as what is given. You can't just say, I sub that in, and I sub the coordinates 5, -3 in, and then I test, oh, it's the same, I will get -2 and -6. That's not working. Okay, that's not working. So, show that question. Again, you can't use the result given in the question. You just can't use it, can't touch it. The question will be exactly the same as find that. Okay, what is given, the question will turn into find that. So now it's asked us to find T and find B. You know T is mixed with couple of dilations and reflections, and reflecting the line y equals x. So what we'll do is, we have our original, well, let's write in this way. We have x dash y dash. Okay. That will equals to, I think there are, how many? Reflection in y, dilation. Okay, 3 reflection or dilation. So that will be 3 matrix. But anyway, I will start with our original coordinates xy. The first thing happened is transfer 1 unit to the right and 2 units up. But that's happened first. So I'll bracket that. Just write your matrix. Okay, next thing is a reflection in the line in the y-axis. Is change the x. I will have this matrix. Next thing is a dilation of 2 from the x-axis is changing y. And last one is a reflection in the line y equals x. You will swap the diagonal with the zeros. So I can calculate that. That's x dash y dash equals to, okay, first to row times by column. 0 here, 2 here, 1 here, and 0 here, times with the next matrix, bracket, xy, calculation order must be the same as the transformation order, so you have 1, 2 here. Then keep calculating that. Row and column. 0 here, 2 here, -1 here, and 0 here. Bracket xy plus 1, 2. Okay, again, T1, T2, T3, like right in the front. Okay, right in the front. Like the first one must be get closest to the xy coordinates. Okay, the first one must be closest to the xy coordinates. So therefore we have x dash equals to t bracket x plus b. So t equals to 0 to -1, 0, and b equals to 1, 2. Okay, you can exactly map that. That's what we will have. This question can actually become harder. So if x and b are not in the bracket, if it says in tx plus c equals x dash, you need to do a further step by expanding the bracket. Okay, by expanding the bracket, you times this matrix with that and this matrix with that as well. So you would need to expand to get the C. Okay, but this one already in the bracket, just exactly the same as what you write now. So B is just 1 and 2. Okay, so that's what we have here. And let's keep going for the next one. Solve the matrix equation 1. Okay, let's write it. 0 to -1, 0. That's the equation 1. Bracket xy plus 1, 2 equals to x dash y dash. Give the answer in the matrix form. X equals to mx dash plus n. Okay, this is x. This is x dash. Now what I want is make x to be the subject. Okay, make x to be the subject. In other words, I want to solve for x. Okay, I want to solve for x. So to solve for x, I will times the inverse of that first. So the inverse of that is 1 over AD minus BC. And then I need to swap the main diagonal 0, 0 and negative the other two. Like this. And that will times by x dash y dash. That's the inverse of that. So xy plus 1 and 2 equals to 1 over 2. That's a half. Okay, I'll times the half in. That will give me 0. Half is -1. Put a half in, that's a half. And that's 0. Oh, there's someone outside. Have your x dash y dash like this. And now you have xy. Well, I'm not going to times them together. Why I'm not going to times them together? Because see, that's x. That's x dash. X dash is still separate. I'm not times them together yet. M is here. And then I need to work out my n. xy equals to 0, negative 1, a half, 0, x dash, y dash, minus 1 and 2. I'll subtract that matrix to the side. Okay, subtract that what I plus on the left hand side to the right hand side. But be careful, this is a plus. Okay, you must have things within the form given to you. So that sign is a plus. I don't want a minus. So I will say a plus, minus 1 and minus 2. I will negative both number. And it asks you to state the matrix M and N. You are not answering the question yet. So you must say M equals to 0, negative 1, a half and 0, and N equals to minus 1 and minus 2. That will be the answer. Okay, that will worth 1 mark. So you need to state M and N. You need to explicitly answer the question. Well, I can see it. If you give me the equation, I can see it. Okay, M must be that, N must be that. But it doesn't mean you answer the question. Okay, that was an answer mark. So you need to state M and N. Alright, last one. Find G, the image of F, and the sequence of transformation. Well, the original equation is 2x minus 1. So fx equals to y equals to 2x minus 1. Okay, don't forget what my purpose. My purpose is make xy to be the subject and then sub into the equation, right? Sub into the equation. Can you see my xy is already the subject from the previous step? Okay, it's already the subject. So what I need to do now is just expand row, and column. So from this, I will have my x equals to minus y dash minus 1. And my y equals to a half x dash minus 2. Well, I don't need to rearrange anymore because it's already the rearranging form. That's exactly what I need. I have xy, I need xy to be the subject. I already have xy to be the subject, then just do substitution. So y is a half x dash minus 2 equals to 2x is minus y dash minus 1. Okay, 2x and then minus 1. Just rearrange it. A half x dash minus 2 equals to minus 2y dash minus 3. Minus 2 minus 1, that's minus 3. So 2y dash equals to minus half x dash plus 2 minus 3. So y dash equals to minus a quarter x dash divided 2. That's a minus 1, so it's minus a half. That is a minus 1. And then divided 2 is minus a half. So you need to answer the question in the form of gx. Gx equals to minus a quarter x minus a half. Okay, it's giving you the variable gx here. But what all we have done here is just go for a long way. Because if you know at very beginning in part A, it says x dash equals to, let's have a look, x dash equals to 2 bracket y plus 2 and y dash equals to minus x plus 1, if I'm not remembering that wrong. Okay, that's what we have from part A. Okay, that's from part A. If I can rearrange that, what I will have is y equals to a half x dash minus 2. And then here x equals to minus y dash minus 1. Can you see that is exactly the same as what we have done so far? Like we have done part C, part D, and then expanding. So we do 3 more steps by using matrix. But from part A, we can directly have xy to be the subject and sub into the equation and get what we need for the last part. Okay, for the last part. So matrix is not an efficient way. Okay, matrix is not an efficient way. So some question just force you to do by that method. You just need to do it. Also, you need to know how to use matrix representation to describe the transformation. Okay, to describe the transformation, you should be able to write the matrix out. So what you need is x dash y dash to be the subject, and then you write the matrix. Just like the question we did here. The multiple choice question. Yeah, here, this question. So I want to see what is the matrix. I need to make x dash y dash to be the subject, and then we can write the equation. So basically it's the coefficient of x and y. Okay, it's the coefficient x, y, and then plus the constant at the back. Okay, so that's all about transformation. Okay, so we finish everything transformation. Any questions? Matrix is a topic like most students don't like, but I think if we go for that way, follow a particular method, you should be able to do it. It's not that hard because I think it's quite boring. All the questions will follow exactly the same way. If you know the method, you can deal with all the situations. And we just have those many rules we have discussed about it before. Okay, so all the root, all the power functions, and 1 over something hyperbola form, and 1 over something squared truncus form, and any circular functions, exponential and logarithm. That's all the rules we're working on. Okay. If you don't have any questions, you can just do the revisions. And if you finish everything in transformation, or you feel confident about that, you can start to do polynomial revisions. Okay, we have learned polynomials since year 9, so we just keep learning the same thing. Next week, I will talk about some key questions, like some really important ones. Other than that, I'm not going to go through every single question, but there are enough practice I have given you in my notes. Okay, it covers everything. So just try those questions and see if you can do them.